What is electric charge? Matter is made up of a certain elementary particles. With the advancement technology, we have discovered hundreds of elementary particles. Many of them are rare and no concern to us to the present course. We say that the bodies like glass or plastic rods, silk, pith balls are electrified. What we mean by this? They acquire an electric charge by rubbing. There are two kinds of electrification, and we find that like charges repel and unlike charges attract. The property which differentiates the two kinds of charges is called the polarity of charges. In this module, we mainly understand what are electric charge and fundamental charge, what is charge quantization, what is charge conservation, and difference between conductors and insulators, as well as what is an induced charge. Particles that exert electric forces are said to have an electric charge. Protons and electrons are designed to carry positive and negative charge respectively, and E being fundamental charge. The above discussion suggests that charge is a basic property associated with the elementary particles. We can measure the charge on a system by comparing it with the charge on a standard body, but we don't know what exactly it is that we intended to measure. The SI unit of charge is coulomb, represented by letter C. 1 coulomb is defined as the charge flowing through a wire in 1 second if the electric current passing through it. In other words, we can also define 1 coulomb of charge is the amount of charge equal to 6.25 into 10 power 18 times of the fundamental charge. Therefore, E equal to 1 by 6.25 into 10 power 18, that equal to 1.6 into 10 power minus 19 coulombs. Charge quantization. The charge on any body is equal to integral multiples of fundamental charge. Charge of particles exists in discrete amounts, that means packets. This is called quantization of charge, that is, charge is quantized. And we consider the fundamental charge E as the quantum of charge. Charge conservation. The charge of an isolated system is conserved. It is possible to create or destroy charged particles, but it is not possible to create or destroy net charge. So, the electric charge is a conserved quantity, and net charge before any reaction is equal to net charge after reaction. Electrical conductors. Some substances readily allow passage of electricity through them, others do not. Those which allow passage of electricity through them easily are called conductors. Any conductor will have electric charges, that is, electrons that are comparatively free to move inside the material. Examples of conductors are salt water, metals such as copper, aluminum, and non-metals like graphite. You can see these conductors in the figures. Most of the non-metals like glass, porcelain, plastic, nylon would offer high resistance to the passage of electricity through them. They are called insulators. So electrical insulators are materials that do not allow electric current to flow through. You can see some of these insulators in the figure. Induced charge. Here, if we bring charged metal rod closer to a neutral metal rod, and you can separate charges on the neutral rod, that is, induced charge appears at the ends of the neutral rod. Here, we should note that charge conservation is at work. The earth is large and is a conductor. So, when you separate the charges in a body and allow the electrons to flow to the earth, you can leave a charged object behind. It means if we connect the rod to the ground by a conducting wire, the electrons will flow to the ground while the positive charges at the near end will remain held there due to the attractive forces of negative charges on the rod. Now suppose we disconnect the rod from the ground, then the positive charge continues to be held at the near end.